Sajish,
Sir,
what are the background of those people? They are more into computer science or mechanical or civil, or you have some data?
sir, I think majority are from computer science backgrounds.
Okay, majority from computer science background.
Computer science backgrounds.
Okay, okay, fine.
Excuse me, sir.
Yeah.
Shall we start?
Yes, you can start.
Okay.
Sir, shall I begin, sir?
Yes.
Good morning, all. Thank you all for coming and joining us here today. Myself, Shahana Shuring, will take this immense pleasure to welcome you all for the final day of short-term training program on the topic Smart Computing Technologies and Applications organized by CSE Department of MES College of Engineering, Kuchippuram in association with AICTE. Hope you had a great time yesterday. Today, we have Dr. Shashidharan Sridharan from MES College of Engineering to talk on the topic Big Data Smart Computing Framework. Dr. Shashidharan Sridharan received his BTech and MTech from Government Engineering College, Thrissur, Kerala in 1995 and 1998 respectively. He received his doctorate from the Asian Institute of Technology, Bangkok, and postdoctoral research fellowship from Red Lab Renewable Energy Design Laboratory, University of Hawaii, Manoa, USA. His research interests are in high performance computing, big data analytics, and smart computing framework applied to smart grid. I'm very glad to welcome you, sir. Let me hand over the session to you, sir. Over to you.
Thanks, Shahana. Are you all comfortable? Whether my talk is comfortable to all? Shall we start?
Yes, sir.
Yes.
Clear.
Okay. Okay, fine.
Excuse me,
So,
sir.
yeah. Yeah.
Sir, are you presenting anything?
Yeah, I'm just starting.
But the screen is only.
Okay, okay. I'm starting only. Okay. It's coming now?
Yes, sir. It's coming.
Okay.
Now it is okay, sir.
Okay, fine. So I couldn't see the participants. Kindly trigger me when something is asked. Okay. So we shall go ahead.
Okay,
Good
sir.
morning, everybody. Give me some response. Okay. The topic that I am going to present is Big Data Smart Computing Framework. Big Data Smart Computing Framework. In the title slide itself, you could able to see the two aspects. One, the smart city. Right side, you can see the big data analytics in an animated way. We will see those things in details as the slide progresses. These are the contents that I am trying to illustrate. One, the introduction, then the smart society. Third one, the fundamentals of big data. Then the big data smart computing framework. Then, of course, some case studies of social objective optimization. Some examples with complex value neural network for forecasting, fault identification, security aspects. Then some optimization plugin with particle SWAM, NSDA, etc. And all these examples we are seeing with the help of Smart Society case study. Okay. Okay. So hope you all know what does it mean by smart? Smart monitoring, analysis, and reporting technology. Now, is it clear, no? Whether we are seeing, no?
Yes, sir. It's clear, sir.
Okay. Next, the syllabus and how we pack off. We have seen the fundamental concepts of artificial intelligence, machine learning, big data, edge computing, optimization, etc. Yesterday we have seen IoT, sensor technologies and other things. We have seen a lot of applications in the field of transportation, vehicles, grid, health, etc. Now the question is how we can integrate everything. Is there any research problem which is integrating all these technologies and also adds this big data concepts? Okay, these are the thoughts with which all this 1 week STTP is being planned off, and will conclude with a interdisciplinary research problem where all the disciplines jointly takes up and get into a good index. That index can be the social performance index. There comes the artificial intelligence, there comes the big data, there comes the optimization. Everything is inclusive in that. Okay, so all this last 5 days work we are just consolidating in this. Okay, now next, the abstract, what I'm trying to illustrate. A new class of multidisciplinary research problem for improving the performance of the smart community and smart cities by taking into account artificial intelligence, machine learning, big data analytics, etc. A sample case studies has also been incorporated. Now, as a title slide to give you a vision, this was the vision that the Google Senior Vice President Jonathan got in the year 2009. This was his saying. Data is the sword of the 21st century. Those who wield it, the samurai. So this was put up in the year 2009, 11 years back. Okay. Next, in the first presentation, that means in the opening ceremony, I have shown you the same slide where this ecosystem has been introduced. Okay, this is the technology catalysis ecosystem for human vitality for the year 2030. There you can see different models. Okay, so in the top priority, in the top of the slide, you can see the connected science. Everything is connecting to everything. Okay, so all are interconnected. Okay, next you can see brilliant objects. Okay, then human vitality index and other things, quantified generations, rise of networks, all these things are coming into a different platform when we enter into future years, and this is what is put up for the year 2030. Okay, so these things we are expanding further. Okay, so just keep in mind the important aspects: connect science, entrepreneur ecosystems, new business models, quantified generations, rise of networks, etc. Okay, then you can see augmented reality. In the same figure itself you can see augmented reality. Then you can see data visualization, then uh, the high resolution sensing, actionable data, so different types of hardware, multi-sensory interfaces,
Excuse
this
me, sir.
various, yeah, is
Sir,
anything
I think there is a little disturbance in
is
your sound, sir. I think mic is too close, sir.
okay? Is it okay now?
No, it is okay, sir. Thank you,
Okay,
sir.
fine, thanks. Okay, so these are the things that we put up as the opening remark. Now next slide is what is happening in an internet. What is happening in an internet in a minute? You can see Facebook 1.3 million logins in a minute. Okay, then you can see YouTube 4.7 million videos. Like that, lots of activities happening in a minute in internet. Okay, just have a look. 59 million WhatsApp messages, Netflix, Google, everything contributing to that. Okay. Now, the ecosystem for 2030. So you can see that the various types of devices are mapping into that. This virtual clouds, cybernetic communities, intelligent agents, building ecosystems, all these things are contributing to the future ecosystem of 2030 in terms of computational investment. Now, when we look upon the factories of the future, you can see that everything is controlled by sensors, IoT sensors, modular equipments, computer visions, robots, cobots. What is cobot? It is given in the bottom. Then wearables are the with which persons can lift different quantities of and quantities and volumes with assistive technologies, etc. Then augmented reality, predictive analytics, all these things are coupled to the future industry. Okay. So somebody was presenting about the industrial revolutions where all these things has been discussed in brief. Now the next is the smart society. The smart society. So slowly, as I have given in the beginning, we are entering into a consolidation of all these applications into some index or something with which we can analyze what is the performance of so and so community, what is the performance of this smart city, what is the performance of this country, etc. Okay. So next is smart society. So the quality of life. Okay. When we are telling smartness, it should mention about the quality of life. Okay. So what is the quality of life as per some index? Okay. This is the global human development index mapping. Okay. So what is this human development index? So you can see in red lines is the statistical composite index of life expectancy, education, literacy rate, gross enrollment ratio at various levels, and net attendance ratio, and the per capita indicators which are used to rank countries into 4 tiers of human development. Okay, see the color of various countries, see the color of India, see the color of US. Okay, so see the color of Australia. So see the development in terms of the index. Just to have a vision, I have shown you this in the beginning. Okay. So all these things are calculated and mapped as per UN guidelines. Okay. So we are going ahead. Now, there is something like sustainable development goals. That is 17 goals to transform our world, which was put up for 2030. It was set up in 2015 by United Nations. So these are the 17 goals for transforming our world. Okay, as per UN, these are the 17 goals which has been formulated to transform our world, which has to be applicable in the coming years, and especially the target has to be achieved by 2030. So envision 2030. Okay, so you can see poverty, no hunger, good health, quality education, gender equality, everything is there. Clean water, work atmosphere, industry, inequality reduction, all elements in this earth are being taken care of by the 17 goals as envisaged by UN. Okay. Now we are slowly going ahead. The smart society. So what is the smart society? A smart society successfully harnesses the potential of digital technology and connected devices and use of digital network to improve people's lives. You can see that the figure in the bottom. There you can see smart mobility is there, smart home is there, smart society is there, smart care, hospitals and other things are there, smart buildings are there, smart energy is there, powered by IoT, powered by sensors of various types and various devices installed in various applications. All these things are also part of this big data in cloud or whatever fashion it is. Okay, so this is the society that we expect by the year 2030 at least. Now, when I'm telling this, I don't know how far you could able to visualize. Okay, this is a smart society photo given or released by China in internet. So it is the figure of Wantan in Shanghai city, China. So see how beautiful it is and how the life and other things. We will see one video of around 2 minutes to give you some idea about how smart the life. Okay. So have a look this video. Could you able to hear? Could you able to hear everyone? Could you able to hear the video and see the
Yes, sir.
video? Yes. Okay. So see here.
Hello? Okay, okay.
The smart life. Go into office. Automatic switch off. All these equipments are being controlled automatically. Have you seen? Yes or no? Is it clear?
Yes, sir.
Okay, okay. So we are going ahead. Everything is controlled by digital devices, the totally automated and comfortable life for the community. Okay. This is what smart society promises. Okay. Now, when you think about the future, maybe 2050, what will be our requirement? What is the nature of various uh, this equipments? What are the various industries, etc. This is a small video to give you an idea about the future. Okay.
to see vehicles with stowaway steering wheels and more leisurely social seating arrangements. All areas of travel will be vastly different by the year 2050. Uber Elevate should be in full swing, allowing people to travel via e-retail in and around cities. Elon Musk's Hyperloop will potentially be released, which will see passengers travelling at speeds of over 700 miles per hour through giant low-pressure tubes between cities, states, and even countries in Britain. Travel as a whole will essentially be faster, more efficient, and better for the environment if all goes to plan. And if billionaires such as Elon Musk and Jeff Bezos have their way, travelling to space might be a possibility too. Space tourism seems like a fun idea to most of us. However, there are a number of companies working towards making stints in space a legitimate travel business by 2050. Space tourism will likely be resumed in the foreseeable future, but by 2050, a trip to the International Space Station might be as easy as purchasing a long-haul flight to Australia. SpaceX, look, a few others are all pushing the envelope to make space tourism a reality. All have the potential to be replaced by AI. This will result in a massive shift in the kinds of jobs that people do, and the transitional stage will be by far the most challenging. In the years leading up to a vastly automated workforce, it will be the survival of the most adaptable. There will be very few jobs for life, and most workers will be forced to learn new skills and delve into new trades regularly as more and more roles are replaced by intelligent computers. The plus side, however, is that there will be a huge influx of social jobs and work that requires imagination, empathy, and real one-to-one interaction. Healthcare, teaching, and the creatives will all be thriving sectors, as will engineers, mechanics, and repairmen. Other positives to this automation process could, in theory, involve cheaper goods and services. Automated production lines are cheaper to run and are far more efficient. So despite CEOs being eager to hold on to equipment and even food, shopping for any said items will be far easier and enjoyable. A huge development in online commerce could come toward thanks to improvements in drone technology. Amazon is pushing a new initiative known as Prime Air, which is a prospective delivery service that will deliver packages of 5 pounds or less via drone to your doorstep in less than 30 minutes. Prime Air is already being tested and is deep into development, so by 2050, autonomous drone delivery is more than likely to be standard service. Unless our foreseeable future is littered with deadly viruses and more worldwide pandemics, one thing that is for certain is that the global population will increase significantly and rise to a staggering number. Big changes in these industries will be noticed by the year 2050 if we do nothing. Minority, around 86%, ocean thermal energy, which at the moment is mostly renewable but will require storage and grid balance. Green energy will certainly help to bring the planet's carbon footprint down to a minimum and will also definitely a lot to look forward to between today and 2050. And potentially a lot to be worried about things don't get to plan. Technology are inevitable and welcome. However, we can only hope that these advancements will push us away from rising sea levels, animal extinction, and record-breaking summers.
Okay. Now, I think you understood what we need to achieve in a span of 10 or 20 or 30 years. What is the status now? How we should achieve? What are the plans for that? This is the thought. Okay. So UN has defined some strategies for that. Okay. And sustainable development goals is being coupled to smart computing framework as per UN. These are the various claims of that. Okay. So this is the motivation for this type of research and going further into big data, into various applications, smart transportation, smart health, etc. etc. Now, next is where we are. Okay, this is our Indian smart city project. Okay, so there is a site smartcities.gov.in. It was launched in 2015. Okay, and Prime Minister inaugurated the smart city mission in Pune in June 2016. And you can see that in around 100 cities are being shortlisted all over in India to be developed as smart cities. Okay, more details you can go to the website. Okay, now what are the cities in India to be recommended as smart cities? These are the cities in different stages. Okay, next, this was the introductory aspects. Next, we are trying to enter into this big data fundamentals. As I explained in the beginning, my aim is to incorporate this big data and this artificial intelligence concept into various applications like smart health, smart cities, smart grid, everything. Okay. So we need to know some idea about big data. Okay. For that, the next session, theme 3. In that, for additional information, you can also visit my web page, students web page, shashiclass.webs.com, where you can get a detailed explanation about all this individual points that I am trying to address. Okay. Please visit shashiclass.webs.com, where you can see all this detailed information about what I am trying to cover in big data. Okay. For persons who are not knowing this concept, what is this big data? Data that is too large or too complex to be managed using traditional methods, processing, analysis, and storage techniques. Why it is big? What is the speciality? All those concepts. So it's a high volume, high velocity, high variety data. Okay. So very complicated. How to manage, that is the issue. But once we could able to manage, you can do lot of things. Okay. So in a thumb rule, any data that exceeds our current capability of processing can be regarded as big. Okay. Now, what is the role of this big data? You can see that from the big data, you can enter into analytics and we can enter into smart decisions. Okay. So from the raw way, we can focus into smart decisions with the help of big data tools. Okay. I hope you know about the various analytics platform provided in this COVID era, sprinkler and other issues in the state of Kerala. So analytics, how it contributed, etc., etc. Next, the information continuum, the data, the information, the knowledge, the insight, the wisdom, how it flows. Okay, the data, the information, the knowledge, the insight, the wisdom. Now, the big data is having applications in all sectors of life, such as banking, insurance, transportation, education, manufacturing, healthcare, energy, media, everything. Okay, so some concepts of big data I am trying to introduce to you. Okay, so here we are entering into the concept of data warehouse. This is the architecture of data warehouse. Okay, you can see that various data sources. Okay, operational system, then ERP, customer relationship management, flat files. Any details if you want, you can refer to the this bottom. Some expansions are there. More details you can refer to my slides, which is available online. shashiclass.webs.com. Okay. Then storage area, next part. Then warehouse, then data marts, then users were analytics, reportings, minings, and other things. Okay, so this is the architecture of data warehouse. Now, what is this modern concept? Okay, here we can see that data warehouse is there, analytics is there, reporting tools are there, different applications are there. You can see different platforms for that, big data platforms for that, Hadoop, then NoSQL, then the different datas of different formats as being given are being taken to the HDFS, stored, then given to data analytics, and with which you could able to get wonderful reports, decisions, etc. Now, the definition of big data is the term for a collection of data sets so large and complex that it becomes difficult to process using on-hand database management tools or traditional data processing applications. In all definitions of big data, you should be able to expand the 5 V's or more V's. Okay. So the velocity, the volume, the variety, veracity, value. Okay. The V's of big data. Some books has got 3, some got 5, someone got number of V's. Okay, in general, we have taken a 5V description as given: the velocity, the volume, the variety, the veracity, and value. Now, the salient features. Okay, you can see, as explained yesterday, the different type of sensors, RFID devices, all these things are connected into the data. Then you can see that different types of analytics are working based on the data. Then economics are also being worked out. Then the technologies are also there. The different types of data are there. And that means the social data is different from geographical data. So we should find out a way to process this. We should find out a way to store this, to use it every part of the world in real time or almost real time. Okay, so what is the way for that? Okay, so these are the drivers. Now you can see here that there are basically three types of data currently. I'm just telling only three types of data: structured data, unstructured data, semi-structured data. So you can see what are the different types of data as per the figure given in the top: live data, nature data, social data, etc. So we are very much particular about this big data storage. When the data is big, very difficult to handle. Okay, so how to handle this? So you can see that these are the main requirements of storage. We should know what is the type of data, how much you can scale, how what way we could able to retrieve, and how much it is consistent. These are the main things that you have to keep in mind where designing a storage for big data. Now you can see various applications, various data, various models, various analytics, privacy and security. All these things are linked. So applications, as I mentioned, smart health, smart cities, smart transportation, all those things. Different types of data are being pumped into this. Then big data platform will provide a solution, and in terms of decision, in terms of analytics, in whatever fashion we need, etc. So there are a lot of add-on tools in the current era. Okay, big data analytics tools. These are some of the tools which we'll be seeing in detail as slide progresses. Now, these are the detailed set of big data tools. For more details, you just go to the slides, or you can just type it in Google and get more help, more toolbox, more support about this type of tools. Now, grid computing. The entire world is in our system now. In our system now, we get data, we get decisions, we got all analysis, how it works. Okay, so the concept of grid computing. So grid computing can hold the whole world. Now, these are some of the examples to give you more insight about this. So this is a National Science Federation backbone of United States. Okay, so it was developed in such a manner that various provinces of United States are being linked with a high power data network. So this is popularly called by the project of United States as TerraGrid. Okay, so the salient features of this project are as given here. You can see the various research laboratories are being linked. In the top, you can see Caltech, California Institute of Technology. Then Argonne National Laboratory, we put it as ANL. Then you can see this Petersonburg Supercomputing Center, Illinois, then San Diego. All this province laboratories are contributing. And see the data transfer. Okay, so there is a hub in Los Angeles, there is a hub in Chicago, and between that, the data speed was 40 GB per second. Okay, so in between this, okay, this was the part of TerraGrid, the US NSF funded project. Now, when you think about data handling, we need to find out what way we should scale it. whether we should go for vertical scaling or whether we should go for horizontal scaling. Okay, so vertical scaling is as given at the left side, more RAM, more CPU, more storage, whatever it is. Here we are adding more systems. Okay, here only one system. In the scale out, in the horizontal scaling, we are adding more systems. That is the basic difference between horizontal and vertical scaling. Now the big data cube, the big data cube. Okay, you can see an example here in various quarters in various countries devices how it being mapped. Okay, now the concept of distributed data system. Okay, so how the data is being distributed all over the world, how we are dealing with international giants like Amazon, various applications, and even geographical informations all over the world. Where are the servers located? How to balance that? Okay, those things are the points in next slides. Okay, so you can see an example of Microsoft Cosmos DB, which was released in 2017, and you can see that how it is being handled. The data has been handled in various parts of the globe. You can see the location of this servers. You can see primary right is in US. You can see somewhere in the southern side there is another read. You can see in the Asian side you can see one or two. Then you can see in the Australian side we are having another. This is how this Azure Cosmos DB is distributing the data handling. Okay, so we need to balance the load in various servers. Sometimes the data should be replicated, sometimes you have to get the data from the original source. So we need to balance in a suitable way, in such a manner that there should not be any burden to any particular server. Okay, so everything should work in smooth. What are the mechanisms for that? There comes the role of load balancer. Okay, there are different types of load balancer: hardware, software, etc. Hardware, software, etc. Then you can see that the replication framework is there. The data has been replicated as given here in the master slave concept. So in slave 1, slave 2, slave 3, etc. Then there is a concept of map reduce. I hope you can hear. Am I right? Can you hear?
Yes, sir.
Okay. Then the concept of map reduce, how it works. See the animation. See the animation of map reduce. I can explain this if you want. You can see that in the figure. In the figure, in the left side, you can see a database. From the database, we need to find out how much each number. So it passes through in the splitting, mapping, shuffling, reducing all this in between flows. And finally, you will be getting the total data as given in the final research. So this is the concept of map reduce, and this is the same thing that we animated here. Okay. Next is sharding. So it is nothing but the database splitting up. You can see the data is being splitted in horizontal and vertical fashion. So in the figure, you can see that 4 data are there. It is being sharded off into 2, 1 and 2 and 3 and 4. So this is the concept of sharding. So you can see that the database servers are there as mentioned in various geographical locations. So this is the this location of various servers of Microsoft Azure, then Google and Amazon. Okay, so the color indicates the various as given here. You can see in US what is the amount of distribution, in Asian side what is the amount of distribution, and how the data is being managed all over the world. Now, typical Hadoop cluster. Typical Hadoop cluster. Next, Amazon Web Services distribution. Amazon Web Services distribution. See where and all it is being placed. In China, it is there. In Asia Pacific, it is there. Then you can see in US which are the locations, in European Union. Then all these places, it is being located to have an effective balancing. Now, you can handle this with the help of suitable tools. As mentioned in the earlier, you can have lot of big data platforms, look at lot of add-on packages for that, and you can process. There are some other way to handle with the help of some research tools such as MATLAB. Okay. Next is the data analytics. Data analytics. So what is this analytics? You can see that there are three types of analytics: descriptive analytics, predictive analysis, and prescriptive analysis. Okay. So one part belongs to intelligence analysis. Another part as given here. I shall tell you what is the difference. So descriptive means what happened. Inquisitive means why did it happen. Predictive means what is the what is likely to happen, and prescriptive means what should happen. So that is the difference between the various analysis. Next is why we need to see Hadoop. Why we need to see Hadoop. One second. Is it clear? Is it clear? Is it going?
Yes, sir. It's clear.
Okay. Okay. Okay.
Yes, sir.
Okay. Fine. Okay. One second. Okay. Okay. It's moving now. It's moving now.
Yes, sir.
Okay. So next is why we need to think about Hadoop in dealing with big data. So Hadoop is nothing but an open source framework that support data intensive distributed applications, and its the advantage is as given here. So storage and processing, low cost, scalability, flexibility, computing power, then fault tolerance, etc. So you can see the different types of Hadoop ecosystem, then Hadoop 1.0 and Hadoop 2.0. So in 1.0, you can see there is no yarn, whereas it is being incorporated in 2.0. For more details, you just visit the additional ledger notes in website. Then you can see there are a lot of add-on tools which works in Hadoop. So these are the various add-on tools that works in Hadoop. Okay. For various purposes, you can just plug in these tools and you can get the analysis. So different add-on tools in Hadoop. Next is the data replication or block replication, how what way we could able to do it. Okay. So you can see a 500 MB data, how it is being replicated and what is the replication factor and other things. So 500 MB data is block size is 128 MB replication factor is 3. You can see that each B is mapped into 3. So you can see B1 is mapped into A, B1 is also mapped into B, B1 is also mapped into D. So this is how it functions. You are having the data source, you are having the different data platforms, you are having the various applications, and with which you are getting different analytics or report. Then you can also use the different this crowdsourcing applications for data analytics. One such application is Amazon Truck. So mtruck.com. So it's a crowdsourcing marketplace where individuals can use the use of the crowd to get their application suitably run. Now, how this is being linked to smart city. So in the first part, I mentioned what is a smart city, what is the importance, what are the various areas that we should address. And second, I have given you some fundamentals about the big data. Next is how we will couple both. Okay. So there comes the role of big data smart computing framework. Okay. You can see here smart city in the center. You are having smart parking, smart what this sanitation or whatever healthcare or energy or transportation or whatever thing. You should efficiently couple this for the benefit of the community. Okay. So in general, we are seeing it as a 4-layer platform. One is the service layer where the different signals are being tapped into. Then storage layer. Next is processing layer. Next is analysis layer. So basically it works as a 4-layer as given here. So we were seeing this 4 layers in various applications and classes that we had in the last few days. Okay. So we have seen the IoTs and other devices. Then storage layer, HDFS and other concepts in brief we have introduced in big data. We also introduced the various big data tools and technologies in brief. Then go into analysis and reports. Okay. So this is how it works. Okay. So in the bottom, you can see the smart environment, whatever it is. Okay. So as I mentioned, smart health, smart city, then smart transportation, all these things are being connected. Okay. Then it is being connected into big data storage systems. There comes the MapReduce and other things. I hope you are familiar with Google MapReduce. In various Google search engines and even in the Google Meet, you can see that the amount of that data it is being handled is very less. Suitably, this data saver is working. Even in Android TVs or any general application, you can see that data saver comes as a part of Google, and you can save considerably in terms of this bandwidth, in terms of the speed, in terms of this internet backbone, investment, everything. Okay. You can see some applications and it is being connected to analysis and decision making. Okay. So this is in general the integrated platform for smart community or smart city, where you can see that the different supporting features as software as a service, platform as a service, infrastructure as a service, all these things are connected. Okay. In the center, you can see that Hadoop and associated linkings are available with the various type of tools. Now, what we can do with with the help of these tools in the smart computing platform for industry. This is the industrial requirement. You can see augmented reality. You can see predictive analysis. You can see cloud computing is the additive manufacturing, cyber security, predictive maintenance. All these things are part of this. Okay. So with this background, we are trying to enter into the case studies. Okay. So smart city case studies. Okay. So I'm taking you back to just to show you how, what way we are going. Okay. So this is our initial slide. In this, we have seen all the fundamental concept. Then we have seen the different applications. Now we are integrating everything with the help of smart computing framework. Okay. And I will be showing some case studies. Yes. Smart city. Okay. You can see various applications as a part of smart city. Okay. So I'm showing some case studies in United States in a place called Hawaii where I have done my research. Okay. So I'm taking it a small harbor, namely Pearl Harbor in the United States, and it is in the island of Pacific as given here. You can see this orange dot in the left side indicates the place Hawaii. Headquarters is Honolulu. You can just reach in both directions, either in the forward movement or in the backside. Here, I think around 18 to 20,000 kilometers there in the forward way from India through Middle East and going over United States. In the backside, it is kilometers bit less. I think around 15,000 kilometer crossing the Pacific and through China, Japan, this Korea, Philippines, that side. Okay, so this is the location. You can see that it is in between in Pacific, in between this Japan and Los Angeles in the reverse side. There is a small island. You can see only dot. That is the island of Hawaii, and the headquarters is Honolulu. Okay, so world's most expensive place. So there are a lot of projects in smart city, smart grid, and smart community there. And one such project we were involved, we are just focusing. Okay, so this is in brief the smart community in Hawaii. Okay, it's a part of some work that we have done for NSF, this United States funding. Then it's the initiative taken by Hawaii Natural Energy Institute. Okay, so how it is being linked, how all this smart city concept is being linked, what is the role of this big data in this, what way it will give some predictive analysis, what way it will heal. So why I'm taking this is small island, the load is less, the requirements are less, communities are less, city is very developed. That is why I have chosen this. There are a couple of this mainland where mainland in US where this concept is being worked out, but to handle that it's been difficult. And I think this is a suitable example for you to visualize. That is why I have taken the example as Hawaii. Moreover, I have done my research, postdoctoral research in University of Hawaii. Okay, so you can see the various elements of the smart community linking. You can see the smart parking. You can see the smart health, smart waste management systems, smart industry, then smart people, smart home, then everything is being linked into the central framework, central big data framework. Okay, so in this way, we could able to project our analysis only with respect to something. So we will take the case of a small community performance improvement or social performance index improvement of a smart community. That is what we are trying to address in this. Okay. So in this, you can see that in a research framework, this MATLAB is having a lot of advantage. So I'm just sticking on to MATLAB for this analysis. Okay, so a lot of advantage as we all know. Okay, so big data framework is also there in MATLAB as given. We will see how things turns. Now, what we are trying to do, in a vague sense, the problem is to improve the social performance index. What is the social performance index? You know what is being defined by UN. Okay. So in improving the social performance index, you need to address the various stakeholders, smart industry, smart transportation, smart health, whatever it is. There we need to have a lot of applications for big data in terms of forecasting, in terms of finding out fault, in terms of healing the problems, etc. Okay. So the question that may come to your mind is how you will get the big data. From where you will get the big data? From where? How? That is the question. Okay. As seen yesterday, you can see that there are various devices which are directly coupled to that, with which you can directly get the data from data centers. Okay, so you can get the data from the data centers. That is one way. Another way is you can work with some simulators. Okay, provided you have the model. Okay, if you have a model, you can work with the simulators. You can work with the simulators and get the data. Okay, another way is you are having the direct applications working, platforms, everything, data acquisitions or management systems, with which you could able to have a plugin. That is another way. So direct from the field or in terms of simulator or from the existing acquisition system. Okay, so as I mentioned, there are different tools, and here we are using MATLAB, and Python can also be used. Okay, so is it okay? You're getting me? Is it okay?
Yes,
You're getting me?
yes,
Yes
sir.
or
It's
no?
okay. It's okay, sir.
Okay, okay, fine. Next, our aim is to generate the big data. Okay, how to generate the big data? So here we are generating the big data for a day. Okay, as a sample, we are just generating the big data for a day. That means I am taking the sample for 24 hours, 60 minutes. Okay, totally 1440 samples are being generated. And how it is being generated? I am using some this open source simulators for that. Okay, so what I'm trying to do is, among the various pillars of the smart community, as I mentioned, smart transportation, smart health, or whatever it is, we are taking one entity, and from that entity, we are just generating some data, either directly available in the data acquisition system or from the field devices directly, or by running the simulators. Okay, so here what I am trying to do is I'm running some third party open source simulators with which I will get the data. So this open source simulator, why I am specifying is it should work with MATLAB. Okay, and we will write some codes in such a manner that we link those simulators. We will get some results into MATLAB, with which you are going to big data platforms and analyzing and getting some results. Okay, that is how we are planning. Okay, so I'm trying to show you some examples for forecasting this healings or addressing the problems or etc. So the tool that we are used for forecasting the requirements and also for the fault identification and healing before it occurs. The one's problem in this big data platform is, since everything is managed through data, even a small change can collapse the total world. Okay, the next generation war is said to be in data, mm, in data way. That means a small change in the data will make the total country to black off. Okay, everything will be closed, all industries will be closed, all telecommunications will be closed, all power will be shut down, everything is washed off. Okay, so we should be very careful in dealing with the data. So in this data handling, we should also run some programs and see whether everything is taken care in the suitable way. Okay, so there are a lot of testing routines, there are a lot of identification routines with which you could able to be confident about this. We could able to be confident about this. Okay, now this is some data we have generated for the small island of Hawaii called Maui. So Maui is a small island of Hawaii. So Hawaii is nothing but a series of islands in which you are getting the data. You are getting the data from each small islands, and this is one such example. And more details, if you want, you go to the maui-smartgrid.com or Hawaii Natural Energy Research Institute of University of Hawaii. There is also another example of this geographical information system. Pacific Research Center is also functioning in University of Hawaii. Okay, so you can get this data from there in real time, or you can get the data through various tools in simulated way. Okay, here as I mentioned, I have just used some simulators, MATLAB simulators, to simulate and get the result for a day. Okay, simple application I have taken here in terms of voltage, in terms of some this energy balance, etc., etc., for simplicity. Okay, so here you can see that the daily curve floats as given here. Daily curve floats as given here. I think you attended the session delivered by Professor Kurupat, where he was using this clustering techniques and other techniques to work with this type of this low duration curves. Okay, so you can use this same approach and use it for various applications in this smart city domain, and this is one such case. Next is I'm using this complex value neural network to predict the fault, and forecasting applications. Okay, just to show you some examples. Okay, so here I am generating the big data by using simulators. I will run it in MATLAB and show you. Then you can see that a complex value neural network is also being used in where the difference is input signals are complex numbers, weights are complex, results are complex, outputs are also complex. Okay, so we are using it for prediction as well as problem identification and healing. Problem identification healing means you can find out some time before, some cycles before, what is going to happen in the system. Okay, you can find out before, that means cycles before, what is going to happen in the system, and you can heal it before it happens with the help of suitable control strategy. Okay, this is the one application with which we have done it. Okay, so a small problem in which you are generating some, running some models and getting some data as given. This is the big data that I have generated with the help of this software. It's an open source software, so everything is embedded inside. In that you can see that directly you are getting everything I have given as a function to make you understand in a very simple way. Okay, so first we are training a complex value neural network, then you are calculating, then you see what is the difference, and with which you can also predict, okay. As I mentioned, it is an important aspect in national security. So a single trip can collapse the total country. A single trip or a deviation of data can collapse the total country. That means sensitivities. So this is one analysis that we have made. In this, we have seen that you can see one is the measured, another one is predicted. This is a forecasting case. Even in the case of fault, we have predicted in such a manner that if fault is going to happen and we could able to clear it, provided your controllers are very fast acting in nature. Okay, and we are also, our aim is not this. Our aim is not to settle with the small priority of big data generation, small priority of fault prediction, and healing. Our aim is very big in the sense we need to apply these tools for the betterment of community. Okay, we should apply this for the smart city framework. Okay, next, how to go for this optimization? Here optimization means it can be a performance improvement of one of the stakeholding of the smart community, such as the social performance index as defined by UN is the better way to handle, or that is having lots of validities in the scenario. So I'm using two optimizations in this. One is the single objective particle sum optimization. All the toolbars I have downloaded from the central file exchange of MATLAB. Okay, so you can see a lot of toolbars are available, and this is the toolbars that I have used. Okay, so particle sum optimization toolbox, and next one is the NSDA non-dominator sorted genetic algorithm, also being used for this case study. Okay, now how I have proceeded. Okay, so you can compare this with a small state from where you belongs. Okay, let it be Kerala, let it be some part of North India, wherever it is. Okay, so let it be Kerala means you can see there are smart cities coming into picture. That means there will be a smart community living there. Okay, so you can see that smart city one maybe in Trivandrum. So, as per the information given to us, only one smart city is going to be proposed in the state of Kerala. Okay. Anyway, we are just showing this as an example. Okay. So smart city one can be Trivandrum. Smart city two can be in Cochin. Smart city three can be in Trichur or Calicut. Or if it is Thrissur, we can see that smart city four is in Calicut. So like that, four smart cities, smart cities or smart community I can tell is being proposed. Or in a small angle I can tell, like in the Trivandrum or in the Cochin, in the smart city decision, there will be small townships, very developed townships, individual townships. That townships can also be integrated to the smart city. So whatever framework you want, you can attach accordingly. Okay. So smart community 1, smart community 2, smart community 3, smart community 4 is being integrated into one particular smart city project. Okay, so you can see that there are various indicators for that: the smart economy, the smart government, smart people, smart mobility, smart living, etc. I have duplicated this by mistake. Okay, smart economy. So these are the various indicators for smart city. That means we should analyze the performance based on this. We should analyze the performance based on this. This is why I have shown you this performance index of various countries in the world. Okay, I shown you in the beginning the per capita index of various countries in the world and where our country is. Okay, so the same thing here. You can see that we are trying to plot a benefit curve. Okay, we are trying to plot a benefit curve involving these parameters. Okay, the benefit curve in the sense you are having centrally a smart city, around that you are having a smart community. Okay, so you are having a benefit curve as given here. What is the benefit to the smart city? What is the benefit to the community? What is the total benefit? Okay, so this is the benefit curve I have calculated for energy. Okay, based on the tools I have specified. Okay, that is open source software for modeling, with which I have modeled the system, I have forecasted, I have finalized the fault, etc. So this is social benefits curve with which we attach or to this problem as a result. Okay, so it's the benefit to the smart city. You can see that there is a huge benefit to the community. You can see that in terms of these parameters, these are the benefits. Okay, similarly you can see this is based on some model. Okay, this model, if anybody is interested, I can tell at the last what is this modeling. You can see in different community 1, 2, 3, and 4, what are the different components involved. And this is what we given to the open source modeling software with which we have generated the big data. Okay. So this is the benefit curve for energy. Similarly, you can, this is not my result, this I have shown you as a sample for an industry, Similarly, you can see, you can formulate a curve for industry as given here. So you can see the performance, social responsibility, etc., supply chain management, etc., for industry. Okay. Similarly, you can extend this for other portfolios of smart city, smart health, the smart transportation, etc. And we can also find out some index. And we can also find out the index. And you can find out the total benefit curve involving everything. You can also find out the total benefit curve. Total benefit curve in the sense, this much is the benefit of the smart community into the smart grid. Or I can tell like, this is the contribution of the state of Kerala to the global Indian scenario. Like then I can get wonderful achievements in terms of this analysis, Okay. So based on which all our progress are being linked. So there is an index for social progress as given here. One is the basic human needs. Second one, the foundations of well-being. And third one, opportunity. Okay. So this is, there are different types of index, and this is one such index which we can use it for our analysis. Okay. So basic human needs, then well-being, opportunity. Okay. Finally, you'll be getting a value SPI, social progress index. So based on the human needs, you can see the basic amenities are being taken care as medical, water and sanitation, shelter, safety, etc. Then you can see that other things are, our growth opportunities are also being linked to personal rights, freedom, etc. Okay. And you can see that in different countries, different levels of freedom. In Korea and all, they are not even given access even to the internet. Okay. So UN has been accounting this type of this benefits and indexes with which the country is being marked for good living. Okay. So this is the social performance index for the total community or for the total smart city. So this is the way that we take care. And as a conclusion, what I want to tell you is, the case study of energy and its benefit to the community as smart grid can be extended to other pillars of smart grid such as smart environment, smart transportation, smart health, etc. And that overall index can be calculated. Each academic or industrial community can be visualized as a smart community, and the benefits should be passed on to the smart city. Academic communities should take initiative for interdisciplinary research routing into various disciplines. So each transportation can be given to civil engineering. Then the smart computing strategy can be given to computer science. The smart grid can be given to electrical. Environmental can be given to civil. Like that, everything should be coupled together. And for a duration, for a typical class of problem in and around the community, each department should give an index. Okay. And everything should be coupled together to calculate the total community index or smart city index. Also, that is having lot of value, and lot of research can be done in this area. All the technological development should be used for the development of society. In that way only, all this analysis has been formulated. Okay. And there are very good books. One book is Smart Computing Paradigms, New Progress and Challenges. It is available in the market for 25,000 rupees. And you can consolidate this all these things, and I will be showing some programs based on the time. Okay. So you can always contact me. These are my details. Okay. So I'm just telling the major part before entering into the modeling. Okay, so this is the smart grid framework that we are taking as a case study. In this, the project of Hawaii Smart City has been taken. The location of Hawaii, then it is in Pacific, as I mentioned. Then the smart environment in Hawaii is analysis done by Smart Hawaii Natural Energy Institute, which is a part of University of Hawaii. Okay, you can see that various industries are being linked into that. Smart city, smart grid, the smart industry, smart parking, smart health, everything is being linked. And we are just using the MATLAB environment to have some analysis. Okay, then various applications. One is forecasting, another one is fault identification, fault healing, etc. Then big data generation, we have used the simulators, open source simulators. Okay, we can also get from the real-time data interface. We can also get from the data center. The tools can be Python or MATLAB. We are using MATLAB. Okay, we have taken a big data for a day as a sample. Same can be extended to even months or years. So just imagine the amount of data to be handled. Okay, then one such data generated for a day, in MATLAB. Then we also seen the complex value neural network just to predict the this fault and heal it before it happens. Okay, then this is the program that we use. Then this is entering into cybersecurity domain because we are just predicting the fault and healing it before it happens. This is the result that we obtain for a parameter in that big data generated indicator. Then we have used couple of optimization plugins. Okay, so multi-objective optimization by NSGA and particle sum optimization also. And we have seen a small case study of a city in which one smart city is being connected to 4 smart community as given here. And the indicators we have chosen as smart economy and smart government, smart people, etc., smart living, etc. And this is the symbolic model for energy modeling. This is a symbolic model. You cannot see this anywhere. Just to make you understand, I have drawn this. Okay, this is not a modeling figure or anything. Just to make you understand. So you can see the number: smart community 1, smart community 2, smart community 3, smart community 4, etc. You can see the different energy aspects, that is renewable, etc. in that in different colors. Okay, this is used for energy modeling. Finally, we have obtained the social benefit curve, and as a benefit to this both sides, as a benefit to the community, as a benefit to the smart city, like this. Okay, in terms of various parameters for the energy as given here. Okay, then same like this is a sample. This I not calculated. Industry we can also formulate. So total benefit curve by adding all the stakeholdings of health or transportation or whatever it is you can get. And finally you can tell the development of this city is contributing this much to the community as well as to the smart city. Okay, and you can also calculate the social progress index. Social progress index, basic human needs. Then you can see what are the parameters involved in this. Then as a conclusion, I told it should extend as a small project for academic institutions, and academic community should take it as an interdisciplinary work. Various disciplines can take up a part of that and can consolidate and publish lot of research findings in this. And that's the end. Okay, I'll be showing some programs. Is it clear? The problem is clear? All of you?
Clear, sir. Clear.
Okay. Now some modelings, and just closing this presentation, going for sharing the MATLAB window. Is it clear now? My screen is being shared. Could you able to see?
Yes, sir.
Okay, okay.
Yes, sir.
Now I'm just minimizing this and go into the MATLAB program. Okay. So the version I'm working is 2018B, MATLAB 2018B. Okay. And this is how we incorporated this. The first one is complex value neural network. Complex value neural network. As I mentioned, the various sub part, I have wrote it as a separate function for each and everything. Okay. So MAOE Smart Grid project, MAOE training. Okay. This is the training part. Okay. Then validation part, and you are finally getting the result. Okay. So we will see how it works. So close all, clear all, CLC, then I'm just copying that. Okay, is big data is being generated for a day. Big data is being generated for a day. Okay. This I can show you in command window. I am having a little bit interface problem with the this graphs and other things, because the open source software that I'm using is clashing with the settings of the MATLAB. Okay, the settings of the open source software is clashing with the settings of the MATLAB 2018 version of MATLAB. And I need to take it in another version. When I take into another version of MATLAB, the problem is I need to change the date. Okay, when it changes the date, I cannot project. So that is why I'm showing this in command window. Okay. So you can see the values, real and imaginary parts of output. You can see this one. Okay, the complex value output. Okay, then the other part. Okay, so it is working. Complex value neural network is working, and the result I have shown you in the PowerPoint. Okay. Next, how I couple with the optimizations and other things. Okay, I'm going to editor. Okay, in editor you can see the various programs I wrote. In this you can see the main program. In the main program, this main program I wrote for what I'm doing is I'm writing my own program which couples with all the open source softwares and gives you the results. Okay, I'm writing my own programs which couples with all the open source softwares and gives the result. Okay, so this is the optimization plugin. Okay, so you can see that this is the main program. So okay, so in this you can see this is the optimization plugin. Let's see. Yeah, this is the function. This is the PSO program plugin. Okay. So this is the this open source PSO toolbox that I have linked to open source simulator tool. Okay. So here this is PSO Trilaya Vectorized. This is the symbol PSO I have used to plug in. Okay. And there is a function. It's a main program. This is the main program. This is the main program, and this is the function. Okay, you can get each constraint. So this is totally been modeled for smart energy environment. Okay, in the same way we have also modeled for this non-dominator sorting genetic algorithm for a multi-objective optimization. Okay, the same open source tools has been linked to NSGA, open source NSGA tool as I have given, and all these things has been consolidated as a performance index, as given here in the slide. This performance index. So this is the result that we obtained, and you can see a lot of publications in this area. And with this, I am trying to conclude with the remarks. And there is lot of scope for this. You cannot see work interlinking this big data, this open source tools and other things, and you can do a lot of research leading to doctorates. Okay, I am also seeking couple of good doctoral candidates. If anyone interested to do in big data, this analytics part and this smart grid, etc., please contact me, and I have shown you my details. Okay, so please open up to ask any question. Is it clear to all? Is it clear to all? Yes or no?
Yes, sir. Clear, sir.
Okay, okay. Anyone can ask any question.
Dear participants, if you have any queries, please unmute yourself and ask.
Okay, if nothing else, we shall wind up. And I have given you my details. Please feel free to contact me in case of any requirements. Okay. Then anything else, Sajesh?
No, sir.
Okay.
Shahana?
Yes, sir.
Yeah.
Thank you, sir, for your informative session. We convey our sincere gratitude for taking time with each and everyone present here. And I request you all to fill the feedback form which has been provided in the chat box. Now we have a break for half an hour. The next session is quite interesting one on identifying IoT malware and future roads ahead by Dr. Vinod P. from Cochin University of Science and Technology. The session will begin at 12 and please do join 5 minutes prior the session. Thank you and have a nice day.
Excuse me, sir. Sir, your screen is present.
Vinod,
Yes, sir.
are you there?
Yeah.
Okay. We'll start at start 12, okay?
Sure.
Okay. Yeah.
Just start
Yeah.
the program.
Yeah, we should start.
So can I start?
Yeah, you can start. Okay, Sanath.
So welcome back everyone for the second session for today. So identifying IoT malware and future roads ahead with great honor and respect may I invite Dr. Vinod, professor in Department of Computer Applications at CUSAT. He holds his PhD in computer engineering from Malavia National Institute of Technology, Jaipur, India. He has numerous research articles published in peer-reviewed journals and international conferences. He is a reviewer of a number of security journals and is also serving as a program committee member in the international conferences related to computer and information security. Sir, it is an honor to have you with us, sir, for today. Let me hand over the session to you, sir.
Yeah. Just a moment. Okay. Just half a second.
Sure, sir.
Is my slide visible?
Yes, sir.
Okay. So thank you, the entire members from the conference for giving me an opportunity to speak. So my talk today would be identifying IoT malware and future roads ahead. And as mentioned, I'm Vinod. I'm presently working as professor in Department of Computer Application, Cochin University of Science and Technology, Cochin. So this is a brief introduction about me and what I do. I started my doctorate at NIT Jaipur, where I worked on the identification of malware, and primarily I worked on desktop malware for identification of metamorphic malware. Then 2016 2016 to 17 I was a postdoc at MNIT Jaipur, and I was funded with an IACA project, and I was working on mobile security. Then 2017-18 I moved to Padua at University of Padua, Italy, which is the world's fifth oldest surviving university, started in year 1220, and where I had an opportunity to work with the world's famous Professor Mauro Conti, who is supposed to be the student of Andrew Tenenbaum, and I was working on European H2020 project, which is called as Target Smart, and adversarial machine learning. So we start with our talk today, and first we will start understanding what is the general definition of a malware. So basically, malware is nothing but it is composed of two words, that is mal, which is something called as malignant, and ware, which is hardware or software. So any malicious software is called as a malware, and these are the set of applications or program written by the attackers to disrupt the vulnerable machines and to exfiltrate the vital information present in the devices, especially the mobile phone or the computers. So primarily, we say that these are nothing but the set of instructions that are written by the attackers to gain privileges on the compromised machine, to take away the vital information and to spread it across to the hacker community. So if we look at the definition by which comes from a very famous research paper written by Moser et al. 2007, it says that these are the potentially unwanted software that deliberately fulfills the intent of an attacker. So then one of the important thing, if we notice, there is a website called as Virus Total. Basically, Virus Total is an online service which runs in the background approximately more than 60 antivirus engines. And here we, as a end user can submit any malicious file or a file with different file extension. We are able to submit the URL, and ultimately what happens is that these applications that are submitted to the Virus Total are scanned parallelly by a number of antivirus engines, and they will flag these samples either as malicious or legitimate. So if you see the Virus Total statistics that I took recently this week, you can see that the number of submissions, they are the number of submissions for Windows 32 executables are large, followed by Android, then followed by PDF. These are primarily the domain I work with my group, and I collaborate with the researchers abroad. So today's talk would be primarily on Android, because these are most of the applications that are used to control various devices. So if we look at the IoT ecosystem as a whole, so we find that the largely the Android applications are prevailing, and most of the devices are controlled by the Android application. We have the smart home, and then we have in the smart home devices like voice assistants, television, and then we have the washing machine. Then we have the industrial control systems, which are primarily attacked by the malware authors. You would have heard about the Mirai malware attacking the many systems. You would have heard about the attack that was created in the Ukrainian power plant, which is caused by the black energy malware. Then we have invariably many systems that are controlled by the mobile phones, and we have heard about the smart vehicles which are using the Android phones, and it is also used for navigation, and people have been invariably using it for the entertainment purpose. So we have understood that Android is everywhere that we think about. And when something gains the popularity, then it gains the attention of the hackers. Okay, so the hackers, they try to find out the vulnerability that is associated with the device or the application, and they try to play with them to exfiltrate information. So, why we must bother about the mobile malware? So, if we look at the McAfee threat report, a report that is 1 year old, but the latest report is also out, we can see that in the first quarter itself, the number of mobile malware is increasing. Okay, so you can see from 2016 to 2018, the trend, the number of malware that appears in the wild, they are increasing at a large scale. So it is estimated that approximately on an average 20,000 new mobile malwares are seen every day. And this largely happened because of the Android becoming popular. And one of the most important aspect is the large proliferation of the third party app stores. So these third party app stores, they came into existence because it gave the privilege to the normal users to write any Android application using any free tools. Without the knowledge of programming, anybody could write an application and they can submit it. So there have been large number of players in the market. One of the important ones, we know that the Google Play, but these Play stores, they come up with one of the weakness, that they don't have a proper security mechanism to attest given the app is benign or legitimate, benign or malicious. So the Google itself comes with a security mechanism called as a bouncer, which is a behavioral based security mechanism, runs on the QEMU emulator, but it also does a behavioral analysis for a short duration of time. So most of the research papers today, you find that there have been lot of work done where people have identified number of Android applications which are malicious. So to conclude from here, this slide, I want to highlight that the Google Play Store also has infected applications, and these infections are because there are not strict policing mechanism to find out given an app is legitimate or malicious. So if we look at the OWASP IoT vulnerability list, so we find that the first one, the top rated vulnerability is like weak, guessable or hard-coded password. That is, most of the device that comes up, into the market, they are coming with the simple username and password, and the end user who are using it, they in fact they do not even bother to change the password. Maybe like admin123, password @123, which could be easily cracked by the simple dictionary based attack. The second vulnerability that have been reported is the insecure network services. That is, these devices come up with many open port, and if the port is kept open, always it is the interest of an attacker. They do the reconnaissance, they find out the open port, and they enter through the unattended open port. Then the third one is an insecure ecosystem, that is a weakness in the authentication of the applications that are ported on web, cloud, or there can be weak API. And there is a lack of insecure update mechanism. The software, they come with insecure and outdated patches, and this have been primarily reported. If you can open and see the CVE details website or at the NVD website, you will find there are numerous patches available for the devices and routers that you see from the leading market players today. Then the sixth OWASP IoT vulnerability that have been reported is the insecure privacy protection. That is the insecure storage of the personal data, disclosure of the user's data without his or her permission, and the insecure movement of data from one device to another device. In fact, people have started looking onto understanding the data traffic, and they try to find out what type of applications they use. Recently, we also published one paper where we analyzed the Tor traffic and the normal traffic, and analyzing through the Tor traffic, we could also infer what type of an application the user is using, which is actually a privacy breach. The seventh IoT vulnerability that have been reported is insecure data transfer and storage, lack of device management, insecure default setting, and lack of physical hardening. There is no secure boot, and the debug ports are enabled. So these are the top IoT vulnerabilities that have been reported. So this is something that I speak everywhere where I talk about security. Basically, security by design is a reactive measure. So we should understand one important thing, that the attackers are always ahead of the defenders. So there is always an arms race between the attackers and the defenders. What these attackers try to do is, the attackers, they spend most of their time analyzing the system. Okay, so when they analyze the system, they are primarily looking for some vulnerabilities associated with the system or an application, and finally what they do is they try to create an attack. They try to devise an attack and they launch an attack. Once the system is attacked, now the defender's role comes into picture. They will try to first of all learn through certain footprints or the symptoms of the system that the system has been compromised. So once the system has been compromised, they try to analyze the type of the attack, and then they prepare the countermeasure for the system. So eventually what the designers are trying to do is, they are trying to gather the footprint, or they are trying to make the signatures, and they update their signature repository. So imagine a scenario that if there are 1 million attack type, so there will be 1 million signatures that are available in the signature repository. So the problem is that the signature repository is scaling up exponentially. It also requires a good skill to prepare the signature. That means there should be a human expertise who should be involved for making the signature. So what is eventually happening is that if at all a new attack is existing, this signature based mechanism will fail. So the limitations of the reactive based system is, it cannot prevent the risk of never before seen attack. So On the contrary, most of these systems should be proactive in nature. So that means any security organization should have two types of teams. One is a red team and a black team. The red team, blue team, the red team is always trying to compromise the machines as well as the different devices in an organization. So what I want to say is that there should be a strong security group who should be modeling the adversary. So they should behave as an attacker and they should simulate the attack. So once an attack is simulated, the blue team should be evaluating the impact of the attack, and they should arrange the attack on the severity scores. And they should immediately prepare the countermeasures for the attack, which will have large impact on the organization. So they will, and they should actually escalate those attacks which are important, and they should not even give privileges to the attack that are unimportant, and that doesn't create a large impact to the organization. So what I want to conclude from this slide is the security by design should be proactive, in which if we want as a defender to be ahead of the attacker, so we should be always trying to simulate the adversary tactics. So that is very, very important in today's scenario. So what is most important is that whenever a malware attack has happened to an organization, the preliminary activity that has to be done is the malware analysis approach. And what is malware analysis? Malware analysis is nothing but it is an approach of dissecting a malware to find out how this malware work, what is the origin of the malware, what is the functionality of this particular malware, and what impact it is going to create onto the system as well as the network. Largely, there are two techniques for doing malware analysis. One is called as the static analysis. So in the static analysis, basically, the malware researcher is interested to look onto the structure of the malicious code. So without executing the malicious code in the system, so if they are not executing the malicious code, then the system is free from infection. So they take the malicious APK files and an Android app. They try to reverse the malicious APK file using certain reverse engineering tool that we will be talking in the subsequent slides. And they look for the malicious instructions, the strings, the presence of an IP address, and so on. On the other hand, to conclude this, the static analysis, as we saw, it has got two advantages. Like, we are not running the application on the physical machine, so it is the machine is infection free, and secondly, it is fast because we are looking at the code level, we are doing certain analysis. On the other hand, the dynamic analysis involves running the malicious application on a container or a sandbox environment. So when we are running an application on a sandbox environment, our interest is to look at the different infection vector, to look at the memory, to look at specific system calls, to look at the flow of information from one application to another application. So that is what is a dynamic analysis. So you would have understood that by doing dynamic analysis, we are actually running the application, so we get a detailed information about the infection because we can do the behavioral based analysis. But it comes with one of the disadvantage that the dynamic analysis is basically slow. So ideally, most of the machine learning malware analysts, they try to combine static and dynamic analysis. Okay, first they do static analysis to, in fact, to find out whether they can catch the malicious samples. So why machine learning has been prevalent in malware detection, especially in the case of an Android? I will discuss about what we did in our work. So we have seen that machine learning has had shown a history of applications in computer vision and NLP, and it had shown improved performance. Uh, Also, we have witnessed that these machine learning algorithms were there since ages. In fact, deep learning was also there, but it gained popularity because the devices, the hardware cost came down, it became cheap, and the the computational power of the system gained importance, and it increased primarily. So what happened is, like, the time that is required to infer the patterns from these applications, they reduce. So that means the training time reduced. Further, there is a tremendous increase in the labeled malicious applications that you can either download through virus share. You can VX7 is pretty old repository, which I would not recommend. Then you can also download many malicious IoT applications from the Contagio mobile dump. Also, you can download these samples from VirusTotal, but to download these samples, we have to actually sign a contract with these services like VirusShare, Contagio mobile dump, and VirusTotal. So there are a number of malicious applications along with the labels available for us to experiment. So once a sample is obtained, the first important thing that we need to do is to extract features. So basically, what is the definition of a feature? A feature is a piece of vital information that tries to explain the sample and to say that this particular sample belongs to a malicious category or a legitimate category. A feature can be quantifiable, or it could be it is non-quantifiable. For example, if I show the picture of these two flowers, on the left hand side we see the picture of the rose, on the right hand side we see the picture of the lotus. So if we try to build a classifier, the hypothesis function that could be learned is that if the color of the flower is red, I would say it is like rose, and if the color of the flower is white, we will say it is lotus. Now, once the hypothesis function is learned with a trivial feature like color, if I submit a new sample that is an apple to the classifier will wrongly label this apple as a rose, and if I submit a polar bear, seeing the color, it would be labeled as a lotus. So what we have understood from these two slides is feature engineering, or the feature extraction, is something very, very critical in case of machine learning. So we conclude that if we prepare our machine learning models through trivial features or very less feature, then it is not going to scale. The number of features that we extract from a sample is called as the dimensions of the features. So the interest of the hypothesis function of a classifier is to discriminate the set of examples that are mathematically represented by feature vector. So so it wants to discriminate the features of one class from the another class. So that is what is the hypothesis function. So if we look at the taxonomy of the features that we can extract from an applications that are installed on any device, it could be categorized as the static features, or it could be categorized as the dynamic feature. Under the static feature, we can take an application and we can extract the strings from the application using the utility called as the strings. And if the application has some section of code that is encrypted, then the entropy will be higher. So we can mark an application as suspicious if its entropy is basically high. Or we can do an analysis on the bytes that are extracted from the application, and we can in fact represent the bytes in a form of a new feature which is called as an engram. So I feel that you are aware about engram, but for the beginners, if we have a feature called A, B, C, D, and if I say the n is equals to 2, so basically I revolve window size of 2. So basically we have A, B, B, C, C, D collected in the sliding window fashion. People have been also investigating on representing these bytes in the form of an image, okay, and building an image based classifier for dealing with the malicious code. So if we have an image based classifier, basically we are building the file agnostic classifier. So in that case, we can take a PDF, represent it in the form of an image. We have an executable, we can represent it in the form of an image, and build an image based classifier. We can do a low level analysis by collecting the assembly level instructions and create the function call graph or the engram. We can do an analysis on the API calls that are gathered. We can do build a machine learning classifier by counting the occurrence of an API, or we can in fact build a string level matching mechanism. Also, we can do a control flow graph analysis. On the other hand, if we are executing a sample, basically we have the memory footprints of the sample. So we can use some tools like Cuckoo Droid to extract or the utility like Volatility Framework to extract the memory footprints or memory artifacts. We can look for the instruction, we can look for the network traces, we can look for the API traces. So if we talk about Android in particular, the Android file format is an APK file format. It's a wrapper, and it contains many components which is called as the Android manifest.xml file, where the explicit permissions for the Android applications are present. Then we have a metadata, then hardware and software features. The entire Android application is represented or compiled in the form of the classes.dex. So we can do a low level analysis on classes.dex. I will talk about what type of features can be extracted. Then we have the resource folder, where we have the resources of the Android applications. You have the icons, you have the layout of the applications. Then if an Android application is interacting with the system using the low level native libraries, which is written in C, C++, Python, it will be available in the lib folder. And finally, every application has got a certificate, and the certificate is available in Meta INF. So when we talk about an APK file and we want to build a machine learning classifier, what we can do is that from the Android manifest.xml file, I can take out the permissions. I can do an analysis on hardware and software features. We can do an analysis on intent filters. So the intent filters are basically the message passing mechanism in Android to communicate with different components without the same application or across the application. So this is something we are looking at now. For an example, let's say that I have two apps that are installed on any smart devices. One is a recipe app and another is a chatting app. If I run an antivirus on my machine, the recipe app will be flagged as legitimate, as well as the chatting app will be like legitimate. But if these two apps have the intents declared, with which one of the intent in the recipe app is a source, and the intent of the chat app is acting as a sink. So if you imagine my recipe app is like reading the contacts, okay, and sending it to a chat application which has an internet socket connection to an outside world, it can send my contacts outside. So such applications are called as colluding applications. So they cooperate together, and then they send information to the outside world. Okay, so leak the information to the outside world, and this can be always done by using the data tainting mechanism. Then you have services, then broadcast, receivers, and actions. And from the classes.dex, that is the byte code of an application, what we can do is we can generate these smelly files. And researchers have said that if you take one application, it may have thousands of smelly files. So they debate that the number of smelly files in the malicious applications are more as compared to the legitimate applications. But then there has been a debate that this is not even true. But there are a couple of papers which looks on the number of smelly files, and we can do an analysis on the low level instructions, which are basically the opcodes. Also we can have an analysis on the strings, constant strings. People have also worked on something called as application metadata to flag if a sample is legitimate or malicious. They look at the app store and try to find out the number of downloads, the reputations of the user, the frequent updates. They say that the malicious application, they go for frequent update. Finally, they also look at the dynamic analysis. They run the applications on the sandbox environment, and they look for the system call trace as well as the network traces. So these are the features that we can extract. So once the features are extracted, the next important thing as a machine learning scientist we should be doing is we should look at the feature selection. So feature selection is an important step in any machine learning task to first of all identify an outlier, to reduce the overfitting, to remove irrelevant attributes so that our classifier makes less mistakes. And if we have lesser features, then what happens is the visualization can be improved. But this feature selection process is typically a computational expensive non-polynomial problem, because if we have, let's say, 1000 features, and if we are asking to choose 10 subset of a subset of features containing 10 attributes, then it is like 1000 choose 10, which is a very, very huge feature space to explore. So what can be done at this point of time is like we can never get an optimal solution to a feature selection problem, but we can have a greedy or suboptimal space. So what we understand from here is that the feature selection is computationally expensive task. So once the feature selection is done, we can create a classification model using the unsupervised or supervised approach. But this is since known to everybody, I would simply run over this. So in supervised approach, every example is something that you see on the slide. It will be tagged, and the test samples will be not contain a label. The hypothesis function will try to label it. And in unsupervised approach, any unsupervised approach tries to work on two phenomenon, that it will try to minimize the intra-cluster distance, and it will try to maximize the inter-cluster distance. So we have lots of algorithms available. So having looked at the looked at Can you hear me?
Yes, sir.
Yeah, because there was a power failure. So kindly guide, if you have something, either you can type in the chat window or you can unmute and you can just inform me. Okay. So
Sure, sir.
Yeah. So what I'm saying is that the limitations of the traditional machine learning algorithm is one of the most important limitation is that the features that we extract requires the knowledge of the tool that the domain expert has created. So whatever is the assumption that is there when we have created the tool will actually act as a noise we would not see some part of the features. And the feature engineering we have seen is a critical task. So we can use the deep learning architecture as a black box to start with, to present the different attributes and learn the classification label that is generated from the deep learning architectures. As also we have seen that since the computational capacity of the system has increased, so it is not bad to depend on the deep learning architectures, because the neuron itself at every layer will learn different sort of features. So inspired by this, we worked on one of the I present here one of the research work we did with one of the research group at University of De Montfort, UK, where we tried to collect lot of Android applications which have been labeled to be affected, which have been labeled as the malicious applications from the one of the universities, Canadian universities. Reference I will show in the subsequent slide. And our approach was to build the machine learning model to flag an application as a botnet or normal. So the motivation of this study was to also leverage the power of the one-dimensional convolution neural network, because our input vector was a linear vector, and to find out whether an application can be classified as a botnet or whether it could be classified as normal. Also, we compared our work with some state-of-art research work that is done on an identical data set that we will be discussing in the subsequent slides. So, to give a general introduction, maybe I have seen there was some initial lectures on machine learning and deep learning in this workshop, but to just give a general introduction about a convolution neural network. A convolution neural network have found relevance in case of image recognition and detection, because one of the striking feature of convolution neural network is it is spatially invariant. It means that if I have a picture of a cat, okay, imagine that the picture of a cat learns about the convolution network learns about the head. Then basically if this picture is presented upside down also, the convolution neural network will be able to identify the head. The reason is the convolution neural network has got many repeated combination of convolution and max pool, this which can be repeated as many number of times, and finally the output of a max pool will be an n cross n matrix, which is finally flattened and it is given to the dense layer, and the dense layer will classify the input either as a cat, dog, bird, and so on. So basically, this happens because the convolution neural network comes with three important properties. The first important property of a convolution neural network is if we take the entire image, there are patterns in the image which is significant and important, and the size of the pattern is smaller as compared to the total image. And the next important property which the convolution layer tries to identify is that the same patterns might be repeated or it could be sprayed in different regions of the image. And the third and the most important property of the max pool layer is that we subsample the image. Still, the definition of the image will never change. and we can have as many number of layers, repetitions of convolution and max pool. So the output of every convolution and a max pool is a new image. And what happens is that as we move from one layer to another layer, the network tries to learn the higher level features for identification of image. So in our case, the input, so over here you can see this is a linear vector of size 342, because every app that is represented by a row is like a vector, and we convolved over this one dimensional vector different filters, and each filters can be assumed as an n-gram. So if I say filter size of 2, it will just take the first 2 features, then the second 2 features, like that, and then the output is written over here. And then if we take the feature size of 3, filter size of 3, so we will say that feature f1, f2, f3 is taken, then f2, f3, f4 is taken, and this is shown by a blue color box over here. So the output of the convolving lot of filters is the collection of a feature map. And these feature maps are again run through a 2x2 filter to get the subsampled feature. So the output of the convolution as well as a max pool is a new representation of the input. Okay, so we repeat it, and finally we flatten the output of a max pool, which is given to the deep neural network, and the deep neural network gives the output as the botnet or the bot app or the normal app. So we used over here the sigmoid activation function. So the approach of using the feature extraction is through the open source tool called as AndroGuard, which is written in Python, and APK tool. And from these we extracted different categories of features, which are the set of API calls, which I will discuss in the subsequent slides, permissions, intents, command signature. That means in some apps there are certain system commands called as chmod, chown, okay, which are really suspicious because the app tries to change its permission. Then other app characteristics also we observed when we reverse the bot apps, that they have reference to some zip file, some different dex file, and each features were represented in the form of the binary representation. So for your consideration, I'm listing out of 342 features, some features, like for example, from the telephony manager class, we see get device ID, get subscriber ID, then you have send SMS, delete packages. If you come down, we can see some commands like chmod, chown, mount. We have the reference to some extra files that you can see over here. Then there are camera permissions. So after collecting these features, we started with a 2-layer convolution and 2-layer max pool. So our input, as I said, it was a 342 dimension vector, and we have the first convolution layer, and we convolved through some filters that we will discuss in the subsequent slide. So when this blue color filter, they moved through the 342 one dimension vector, we got an output that you see over here. So this collection is called as a feature map. Then we apply the max pool, then the output is given to the second convolution, we apply the filter, then we give to the max pool. Finally, we flatten the output, it is given to the fully connected dense neural network, and then the output layer contained a single neuron with the sigmoid activation function, which labeled the given application in the form of a 342 dimension vector as a normal app, or it labeled it as the botnet. So for this study, what we did is we collected the ISCX botnet dataset from the UNBCACIC website. This is a very good collection of a repository. I would request the audience to have a look onto this, where you can get a collection of network data, the botnets. You can get the Android data, but we have to have a contract with the university. From there, we collected like approximately 2,000 samples, which belong to the 14 different botnet family. And these have been used because these samples were used on this in the state of art work. And we also gathered approximately 4,800 samples from Google Play Store. And these samples applications were submitted to the virus total to attest indeed the application that we downloaded were legitimate. So we had roughly 6,800 samples for our experiment. So we did a comprehensive analysis on the impact of the number of filters. So the number of filters that we use, the length of the filter, that is the filter size of 4, 6, 8, and so, the size of the max pool layer. We compared the one-dimensional convolution neural network model that we created with other machine learning algorithms that were used in the state of art using the same data set. So our data set, we segregated the data set into 80 and 20, where 80% of the data were used for training and remaining reserved for the validation. And if we look at the epoch, we see that after 100, there is no significant improvement. So the model was freezed with a stopping criteria of 100 improvement, as we did not observe any improvement. So if we look at the first analysis that we did, the effect of number of filters, so the total 32 filters that we used, it gave us an F1 score of 0.98. We never resorted onto accuracy because the data set indeed is a imbalanced data set. Then if we look at the length of the feature, so the filter size of 4 gave us an accuracy, an F measure of 0.98, but for others it was between 0.978 to 0.979, a marginal difference. So here the number of filters was fixed to 4. And we also studied the variation of the max pool. So we have the max pools ranging from 2 to 8, and we saw that the max pool of 0.98 gave us the best result. So keeping these three hyperparameters into our mind, which is like the filter number of filters as 32, the length of filter as 4, and the max pool size as 2, we presented the 20% of the test set to the classification model, and we found that our CNN gave us a result of 0.98, and the state of art algorithms had the F1 score between 0.781 to 0.976. So what we have understood till here, by seeing a very good result of 0.98, we understood that, oh, this is a very good machine learning model that could be deployed to identify invariably the IoT malware that is actually using certain Android application for controlling. But if you look at that, the present security by design, it is actually assumed to be deployed on the legitimate environment, which is actually wrong. We feel that we prepare a machine learning model, we deploy it, and there will be no adversaries action or event on it, which is actually a myth. Secondly, we always feel that once we make a machine learning model, we deploy it, we give the test sample, we get a good result. It is because we have a wrong understanding that the test set and the training set have an identical distribution, which again itself is a wrong assumption. Third, what we observed actually is that the data source is diverse, and when the data source is diverse, the data comes with the random noise. So, to this point, I would like to highlight that what I want to say is that in the case of an image classification perspective from a very famous group who works on adversarial machine learning headed by Dr. Battista Bigo from University of Calgary, Italy, under the PRA labs, they say that if you take an image and to this image I spray some random noise, I will get an image as an output. But if a normal human being looks at this image, this still looks as a school bus, which is over here. We cannot identify it. But when it is given to a deep neural network architecture, the deep neural network architecture will classify it as an ostrich. So this thing that you have got over here is something called as an adversarial example. Now, what is an adversarial example? Adversarial examples are basically an intentional disturbance or perturbation created by an attacker onto a legitimate input so that it is barely recognizable by human being, but our classification algorithm will try to make mistakes on the adversarial examples that have been inputted. So there are many techniques of creating adversarial examples, which is actually far from our talk today, but still I would give some notion. There is something called as fast gradient sign method. You can actually investigate on the tools like Clever Hams to look at. There are a lot of GitHub repositories available for these. You can look at it and create your adversarial sample. So, what is the reason for all these adversarial attacks that are happening? The first important problem is called as concept drift. So the concept drift means that we have a machine learning model prepared, and we assume that the machine learning model that we have prepared will be able to identify the new instances, which is basically wrong. So there has to be some active learning mechanism that should go in the background for future the periodical update of our model. Secondly, most of the machine learning models, especially in the domain of the security, have been trained using superficial features. As you have seen, people like in the slide previously, they have been trained using some metadata opcodes which can be easily tweaked by the adversary. And in case of images, we have seen that they have been trained with some histograms of features applying the local binary pattern or the GLCM algorithm, which can be easily tweaked. Another important observations from the research community, they have found that most of the machine learning model, as they are constructed from a higher dimensional feature space, the irony is that in the higher dimension, the classification algorithms, they start behaving linear. And the attackers have been very smart. Instead of attacking the contributing features, they start changing small features from, they start disturbing by small amount to each attribute, so that the classification algorithms, they try to make mistake, or the classification is actually fooled. Finally, what I want to conclude is that the classification algorithms, they don't have the generalization capability. So at this phase, we have three types of an attack model. So the first attack model is called as a white box attack. In a white box attack, the adversary basically has complete knowledge of the training data, the representation of the features, and the classification algorithm. So when I say the classification algorithm in terms of the neural network, the attacker is aware about the architecture, the weights, the number of layers, the activation function. You can try to think that how such an attack is possible when we have a machine learning model that is deployed. Do we open everything to the attacker? Basically, this attack model is not realistic, but it is realistic in terms of a defender. So if as a defender, if I want to actually check the robustness of the machine learning model that I'm going to deploy, so I should mimic as an attacker. I should actually have a white box testing of. I should launch a white box attack on my system to find out whether it can be compromised. However, the threat models are basically gray box. So in the gray box, the attacker is having a knowledge of the basically the feature representation and the classification algorithm, but the attacker is not aware about the training data. So when I say the attacker is unaware about the training data, but the attacker can collect the training data that is occurring in while. That means the attacker can collect the surrogate data from different data repositories. The third one is called as a black box, and the most complicated form of an attack in which the attacker or the adversary is unaware of the training data. She is unaware of the feature representation and the classification algorithm. So, if we look at the complexity of the model, the complexity of the attacker's knowledge in case of the black box is less, but the knowledge increases when it is white box. So, having taken this into consideration, I'll come to this slide bit later, so that so having taken this into consideration, what we did is like we launched a black box attacks on the machine learning model that we created previously. So in the black box attack, basically what the attacker is trying to do over here is the attacker is trying to mimic the parameters of the black box machine learning model. So you can imagine that this is a black box machine learning model available with the defender, and I am an attacker. I want to actually fool this model. So first of all, being a smart attacker, what I will do is I will first start with a collection of machine learning algorithms, okay, and I will collect the surrogate data, which I as an attacker know that some samples are legitimate malicious applications, some samples are malicious applications, okay. So here we assumed one thing, that we are having a privilege of submitting infinite samples to the black box machine learning model. Also, we were able to learn the output that the machine learning model gives. So this is the assumption that we started with. So initially, as an attacker, I will submit the benign application. Also, I will submit the malicious application to the black box model. Having done this, what happens is that I as an attacker can see the labels that the model is giving to me. So either it would be benign, that is legitimate, either it will be malicious. I will take these apps that I got as an output from the black box model. I will present it to different algorithms that are used. Okay. And I would see whether which algorithms are giving me the correct output that was obtained from the black box model. So let's say that I have a subset of such models available. I will repeat this task with large collection of the samples. That means I will learn the output from different output of the black box, and I will submit it to the my own machine learning algorithm, and I will try to infer basically which are the collection of the machine learning algorithms that are giving me the best result. In the same time, what I'm doing is that if my algorithms are making mistake, I will try to tune the hyperparameters and see whether I can get the best result. So this task will be a time consuming task for an attacker, but as an attacker I even don't bother for it, because my primary intention is to fool this particular black box model. Now, once I see that my model, machine learning models are trying to approximate the output that is given by the black box model, I will try to do some gimmicks over here. I will take my malicious sample, I will add some random noise. So what is the random noise? From the benign application, I will try to find out those attributes that are significant to identify a sample as benign. I will spray that particular uh, attribute if not present in the malicious application, and I name such application as an adversarial application. Then I will submit this adversarial application and the legitimate application to my black box. So the black box will give me two answers. Either the answer is benign or the answer is malicious. But purposefully I have written over here adversarial because the distribution of this malicious sample is closer to the benign. That is how I have written here adversarial. But this may still try to classify this sample, malicious sample, with a confidence. Let's say it will say with 50% or 60%, it will say that the malicious sample is indeed malicious. So I will keep on increasing the level of noise in such a manner that the distribution of the adversarial sample is very, very, very closer to the benign sample. And this adversarial malicious sample is classified as adversarial with a probability of, let's say, 80% as very less percent as malicious. So once I have learned that I can try to bring my malicious application to a distribution of benign, what I will try to do next is I will increase the noise and I will submit the adversarial samples to the black box. The black box will give me with a very low confidence that a sample is malicious. It will try making the mistake. So I will try to increase the noise again. So eventually what will happen is if I submit the adversarial sample, the black box will now send me an output as benign. So if you look at, I have learned the distribution of the adversarial samples. So then what could be the countermeasure to this problem? So one of the countermeasure to this problem is to tackle this problem as an n+1 classification problem. That means benign, malware, and adversarial. So what I will do as a defender is, like, I will make use of the model that I prepared previously over here, and I will create large number of adversarial samples. And by adversarial samples, I mean that my examples are tweaked. Indeed, it is malicious, but the classification algorithm is trying to make mistakes. And I will recorrect the label of the samples that are wrongly classified, and I will retrain my machine learning model. Okay, so in that case, what will happen is if an attacker is now submitting a adversarial sample, we know that it will be labeled, it will never be labeled as malicious. However, it will be labeled as adversarial or legitimate. Okay, but this task is pretty complex because when we are using this mechanism, our hypothesis function will become highly non-linear in nature. It might somehow try to overfit, so we should have a strong regularization model implemented. But uh, there are another techniques that are available to this context, which is called as defensive distillation. So in defensive distillation, we actually try to smooth the probability values. So maybe I feel that you can look on. So what are the open research issues in this particular domain, specifically on IoT malware detection that we have found? Is first of all the class imbalance problem. So if there is samples from a lower a class that contains large number of samples, always the classifier will be biased and it will try to identify samples of the large number of samples of the class. But this can be dealt by creating the using the upsampling methods, or you can also create synthetic samples using the generative adversarial network. Second contribution that can come from our part is by identifying the malicious samples that are existing in wild, properly labeling the malicious sample using our own tools and making it publicly available for others to use, and to put a remark on the samples. Then the third one is called as the concept drift. So in the concept drift, we need to identify whether the machine learning models that are trained with the historical data are proving to be better, or we should make use of certain active learning techniques. We should apply different adversarial example creation techniques to find out the adversarial feature space. We can also work on the categories of obfuscated malware samples. Obfuscation is a technique that was primarily used by the security researchers to allow not to disallow the attackers from cracking the software. But now the hackers, they were inspired by these approaches, and they used obfuscation as one of the important tools to hide their malicious payload and fool the machine learning based classifier. Last and important work that is still an open issue which can be looked on is when we try to do the analysis of malicious applications on the container or a sandbox environment. These malicious samples, they detect the premises environment and they stay dormant. So we can do the identification of evasive malware samples using certain techniques. So uh, this is what I had for the lecture today. If there are certain questions, maybe we can take up. I have some extra slides, but I would like to take up some questions if they are there.
So if you have any queries or concerns, participants, please do ask.
You can type in the chat window also. I can read and maybe I can try to answer.
If any participants have any questions or queries, you could type in the chat box, or may I unmute and ask. Also, you can raise your hand. Anyone?
or if it can be also sent as a mail if there are no questions to be asked now. Maybe they can refer to the slides as well as the videos, and if they want to ask, they can in fact write to me. My mail ID is also here.
Sure, sir. So I think everything is clear. Thank you, sir, for joining us. We are really enlightened with your knowledge and presence. Thank you so much, sir.
Thanks for having me. Once again, I thank the head of the department and all the organizers for inviting me and giving me an occasion to speak. So I wish everybody a Merry Christmas and a Happy New Year to come. So shall I leave then? If it is over.
Sure, sir. Sure, sir.
Okay.
We are so
Okay.
glad. Thank you for your presence, sir. Thank you so much.
Thank you. Thank you.
Thank you very much, sir.
Thank you. Thank you.
The feedback link is provided in the chat box, and there is an important announcement for you. As per the AICTE regulations, a test shall be conducted at the end of the program, and the certificates shall be issued to those participants who have attended the program and have scored minimum 60% marks in the test. Accordingly, we have planned to conduct an online test today afternoon session. There will be 25 multiple choice questions. You need to answer all the questions. The link will be provided to you during the concluding ceremony through Google Meet chat window. You need to complete the quiz on or before 8:15 p.m. today. I'll repeat once more. There will be 25 multiple choice questions. You need to answer all the questions. Every questions are compulsory for you to answer. The link will be provided to you during the concluding ceremony through Google Meet chat window only. You need to complete the quiz on or before 8:15 p.m. IST today. So I think that's clear. Now we'll have a short lunch break. We'll meet you again at 3 for the closing ceremony. See you again at 3. Please join 5 minutes prior to the time. Thank you so much. Thank you everyone for your presence. This is me, Sanat Mulli, signing off. Thank you so much. All participants, please fill the feedback form as soon as possible. Thank you so much.
Hi mate. Hi mate. How are you?
Fine.
Okay. Our function is at 3 o'clock here. That's
Oh,
of time.
okay. You're still online, right?
Yeah, we are online.
Okay. It's still up, right?
Eh?
The program is up.
No, program now lunch break here.
Okay.
Lunch
So
break.
it's clear?
All program finished. Only concluding function. That is at 3 o'clock.
Okay. My sound is clear.
Yeah, it is very clear. It is very clear.
Okay. How about the video? It's okay.
Yeah, video is also clear. Everything is fine.
Okay. So ready, no?
Yeah, ready.
Ready. Thank you, Sasi.
Okay.
Oh, very great
Okay.
event.
Thank
Yeah.
you.
Okay.
Okay. സജീഷ്.
Sir.
ഓക്കെ ഓക്കെ, ഞാൻ ഒന്ന് ടെസ്റ്റ് ചെയ്ത ഇവിടെ.
Okay, sir.
ശശികുമാരൻ സർ. ശശികുമാരൻ സർ. സാറെ കേൾക്കുന്നുണ്ടോ? സർ, ശശികുമാരൻ സർ, മൈക്ക് ഈസ് മ്യൂട്ടഡ് ഇറ്റ് സീംസ്. സാറെ കേൾക്കുന്നുണ്ടോ? സാറിന്റെ മൈക്ക് മ്യൂട്ടാണ്. സാറിന്റെ മൈക്ക് മ്യൂട്ടാ. ഇല്ല, ഇവിടെ കൺട്രോളില്ലേ. ഞാൻ നോക്കട്ടെ, ഇവിടെ നോക്കട്ടെ കേട്ടോ. ഓക്കെ.
ഇപ്പോൾ ഓക്കെ ആയിട്ടുണ്ട് കേട്ടോ. ഹലോ, ശശി ഇപ്പോൾ ഓക്കെ.
ഫൈൻ സർ.
ഇപ്പോൾ ഓക്കെ.
ഓക്കെ ഓക്കെ. We shall start at sharp 3, sir.
Yes, okay.
So we shall start. Comparing team, please take it up further. We shall.
Okay, sir. Sir, let me start the session.
Good evening, everyone. Myself, Sahela Parakal. I am personally feeling equally overwhelmed and overjoyed to have seen this 6-day short-term training program on the topic Smart Computing Technologies and Applications, organized by CAC Department of MES College of Engineering, Kuttipuram, in association with AICTE, has come to a conclusion with so much for each and everyone to take back with them. As quoted by our former President, Dr. APJ Abdul Kalam, Learning gives creativity. Creativity leads to thinking. Thinking provides knowledge, and knowledge makes you great. Let us begin the concluding function with the blessings of God Almighty. For the same, may I invite Ms. Ranin.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين آمين.
Thank you, Ranin. Now, I would really like to invite Professor Shajish KU, Program Co-Coordinator, for the welcome speech. Over to you, sir.
Thank you, Sala. A very warm good afternoon to all. Welcome to the closing ceremony of STTP on Smart Computing Technologies and Applications. It has been intensive 6 days, inspiring, thought-provoking, and wonderful technical talks. And today, we are here to conclude our event. We have learned a lot, and I am very glad that I still see so many people stayed behind to attend the closing ceremony. Thank you, one and all. Let me come to my duty of proposing welcome speech. First of all, I propose a very warm welcome to our honorable chief guest of today, Dr. Shashikumaran Sridharan, former chairman and professor, King Khalid University KSA, and CEO of Media Technologies Training and Software Solutions, Trivandrum, to preside over the function.
Thank you.
Next, we have our esteemed guest of today's function, Dr. Aimed Wardana, University of Malang, Indonesia. I warmly welcome you, sir. Your presence is a great honor for us, great inspiration too. I would like to welcome Dr. Shashidharan Sridharan, HOD and coordinator of this STTP. He is a crucial guiding factor in shaping the phenomenal growth of our department. I consider it's my privilege to welcome you, sir, to this function.
Thanks.
Lastly, I feel honored to welcome all the participants and my fellow colleagues for taking a keen part in this program. I am sure that you all have learned something new from this program. I welcome you all again to the closing ceremony. Thank you. Thank you very much.
Thank you, sir. No event sums up without a formal inauguration, and thus may I invite Dr. Shashikumaran Sridharan, CEO and former chairman and professor, King Khalid University KSA. He earned his PhD in Computer Science and Engineering from University of Roorkee and MS in Electrical Engineering from Kerala University. He had around 10 years of experience as chairman of department in King Khalid University, Saudi Arabia, and around 38 years of academic experience as professor and chairman, assistant professor, senior lecturer, and so on. Sir, it is our honor to have you with us today. Over to you, sir.
A very good afternoon to all of the people. I guess that the participants are drawn from all over across the country. I see something like 55 people in this group, and I was told that around 100 people registered, and 55 only turned out or continuously available, which is one way it is a bad thing as far as academics are concerned. So first of all, I would like to convey my regards to Professor Shashidharan Sridharan, the program coordinator, and Professor Shajesh KU, Principal Varadarajan, and the management for inviting me to do this a very important function as far as the program is concerned. We teachers today are in a confused state, majorly because the profession which was supposed to be the number one preferred choice among the people, today slowly the position is getting behind so many advanced technologies. We do not know what is happening in India. Almost 50% of the seats are vacant. Only 10 to 20% of the students are employable. And a lot of chaos happening in this country. Those who are capable and non-capable are running the institutions. Many reasons are being taught, obsolete syllabus. Many issues are being taught about this one for the last so many years. And we are now coming to with a new education policy, MEP 2020, which gives us a lot of inputs and a lot of facilities to make this education more vibrant than what is happening now. One thing is very clear. There are issues. Maybe the curriculum, which has no provision to have a dynamic change. The teachers who are interested only to get the degrees, and they are not able to provide the right kind of requirement of the graduate which is required by the industry. Technology gap. So many issues are being talked about that. The training of this kind of things is very, very important, particularly because of smart. The smart is a buzzword today. Smart system, smart technology. Almost all things are being controlled through IoT systems, where the wireless is the backbone. The moment which is the wireless coming into picture, a lot of security issues are being coming, and a lot of threats are going because the IT penetration is going up. So almost all things go beyond our control. So many issues are coming out. So that shows that there is a change of the things happening in this country, where new technologies is going to place the position of the old technologies, which compels us to provide the right kind of curriculum, a curriculum from a rigid system to a non-rigid system, where you are able to provide the right kind of technology at the appropriate time. Because you see, today, the technology's life is almost like 2 years only. When you make a curriculum, we will work for 2 years to make the curriculum, and another 4 years to come out first batch of the student from the new curriculum, which means that there is a technology gap of minimum 66 years. And by the time the graduate coming out, he is not fit into the changing scenario. There where we are struggling now, which shows that there must be a mechanism for dynamic change of the syllabus, curriculum as per the needs of the industry, and the teachers must be equipped with the new technologies as well as new skill. Before that, all of us who have taken PhDs thinking that once you have a PhD, you are the right teacher. Unfortunately, today, that is only a starting point. The teacher must have PhD, of course, it is essential, but that is not sufficient to survive in the new technology era, where all the theories and technologies are available on the fingertip. So the teachers have to find out to get them equipped with the new technologies, one side, advanced skills which are required for the industry, at least 2 or 3 skills, at least 2 skills must be there. When I say skill, which is a confused word, skill is higher level skill, advanced level skill. Somebody in the, for example, cyber computing, you should have the knowledge of certification program, like that. High technology skills are required. And then he should have very good concept about what are the accreditation policy and what are the things behind a outcome based education, where the teacher is or the university is accountable. So creating a syllabus just for nothing or some names, conducting some examination, evaluating the student as first grade or honors, things like that, the days have gone. Today is the days where nobody bothers about your higher percentage. Of course, there is some weightage, but if you are not trained by your teacher with the required technology at the appropriate time, your graduates are not wanted. As I usually say that today, the branding is not sufficient alone. Of course, there is a percentage of job available for branded institutions, but other institutions purely depends on the quality of the graduate with the latest technology, which means that a lot of effort has to be taken. The widely talked subject, industry institute linkage. Even my graduation time, 73, we heard about industry institute linkage. Even after so many years' time, still the industry is far away from the institutions. The industry is far away from the education system, and which will lead to survival of the fittest. Which institute is able to provide the right people, the right teachers, the right syllabus will survive. Others will have to go away. In addition to this one, the new post-pandemic scenario is creating anguish among the teaching system. You know that the technologies are changing a lot. New technologies have to come. Then who teach the new technology? The new technology available with only few experts. So interactive online platform is likely to have at least have a major stake in our education system, which means that what I see is that by involving in this activities for the last so many years, I find that that tomorrow we are going to have an hybrid system where the new technology will be taught by the people from the industry. That will be only through e-learning system. So the mindset has been totally changed to adapting to new online learning systems, and it is going to continue, which means that once Government of India, MHRD, UGC decides to incorporate hybrid learning as also in our curriculum system, I'm sure that the 1:2:6 concept of teacher-professor ratio will change. So which means that the teachers will be under threat in the coming years unless they equip ourselves with the new technology and the right skill which the industry need, because the management is not going to tolerate keeping the teachers who are just with a PhD and doing nothing. All the things, as you know, that today the students are more brilliant than teachers. They get everything from the internet. So they don't want a teacher which only talks about just theory alone. Some sort of a research and all, okay, at the postgraduate level, accept. But the other teachers who are teaching, for example, somebody teaching in the data structure, the theory teaching, nobody wants it. You get immense PowerPoint available, all short notes available about data structures, but they look into a teacher who can apply data structures for some applications. So the threat for the teachers are definitely going to happen. So the ratio, once the Government of India decide to shake the ratio, the manager will no longer keep most teachers. They will have only minimal number of teachers will be kept, and the hybrid system is going to happen in the once the post-COVID scenario. So I'm very happy that MES, which is one of the most wanted colleges among the parents today, has come out with a wonderful, concept, smart computing technologies and application which are covering almost all new technology areas, right from AI to machine learning to I'm seeing a very nice, program is made which covers about IoT and machine learning, big data, and so on. All the things are ML. Everything is there. Of course, I wish that one security subject also could have been included here because the most of the things security is now coming into play. So there is a thinking that even everyone must be given basic knowledge about security issues, which is what the latest approach, right from the +2 level, because everyone is using internet today and nothing is secure here. People use mobile very extensively, no security is there. So everyone has to be taught little bit about the cyber security fundamentals so that everyone has to be secured by himself. So at the user point of view, a lot of things are happening, a lot of programs being offered by various organizations, particularly EC Council, where they are the only body available worldwide who are the authority in this domain. So with these few words, I congratulate the MES system introducing such a wonderful concept, smart computing applications, and I am sure that the teachers who are benefited from this, and remember that each area need a further expansion. The teachers who have interest in some of the areas definitely have to get highly skilled as well if they want to survive. With these few words, I am happy to inauguration, right, Shashi?
Inauguration or
Yes,
concluding
sir.
function?
Conclusion, inauguration and conclusion of this program. And I wish all the best to all the participants and request all of you personally that don't stop with this small training program. You must continue. You must update yourself because each area is most important, and we are going to see a lot of new BTech level programs are going to come, and already few programs are already out, and I'm sure that smart technology will be going to sit in the future, and new areas will have to come. And remember that even if new areas come, the life of the BTech program will be only limited to one course, one graduate level who come out, because they cannot survive unless, and that also I'm sure that the 6 years which I was talking about will not have the life. So there must be a mechanism to change the curriculum very often, which is normally possible not with a rigid system. It is possible only when we have an autonomous system. And I'm very hopeful that India with the MEPs implemented, lot of colleges will come, and I'm sure that MES also will be, already they have got a reputation, they have got a stamp among the employers, and I'm sure that MES also will be one of the competitors to try for accreditation, so that the whatever the bottlenecks that you are facing with a single unit, single what they call university system, and you will be able to provide much more than that. I again wish you all the best, and I take this opportunity to thank all of you and also the management for giving me this opportunity. Thank you very much.
Thank you, sir. With great honor and respect, now may I invite Dr. Aimir Vardhana, Senior Lecturer at Directorate General of Higher Education, Ministry of National Education, Indonesia. He has been a lecturer at ITN Malang, Indonesia since 1992. He has also received his doctorate in engineering from the Asian Institute of Technology, Thailand in 2012. Over to you, sir.
Thank you, Sirak. Good afternoon, everybody. Respected dignitaries and dear participants. First of all, let me congratulate the GSE Department of MIS College of Engineering for arranging such a wonderful and informative training program on smart computing technology and application. As you all know, smart computing is quite an existing field to study. It is all around in this modern world. It finds its application in almost every aspect of our life. I am really happy that you have organized a training program on such a trending topic during this COVID era. Secondly, let me congratulate all of the participants who have taken an interest in attending this program. And I'm sure that they all have learned something new from this program, which will boost their knowledge. I once again congratulate everyone who has taken their effort to make this program a great success. Thank you very much.
Thank you, sir. For the program report and feedback, now may I invite a pleasant and familiar face to all of us, Dr. Shashidharan Sridharan, Head of the Department and Program Coordinator. Over to you, sir.
So, good afternoon, everybody. Good afternoon, Shashikumaran sir. I made Vartana.
Thank you, Shashi. Good afternoon.
Finally, our 6 days effort came to a comfortable end. Some facts and figures for those who are not present. Total number of sessions conducted 16 sessions. Number of persons handling the session 12. 4 persons were handling 2 sessions. International dignitaries 4. Inside the state 4 dignitaries. Internal 3. Outside the state 2. Industry 1. Okay. So that is how it is being mapped. Regarding the participants, 160 plus registered, 130 plus confirmed, 60 plus attended. Okay. So we got funding from AICTE to conduct offline training program with which it was changed into online mode. We have conducted one and remaining we can conduct in a span of 6 months. As per the circular given to us yesterday, we can conduct 2 more programs subject to the maximum limit allocated, and we are planning to conduct 2 more programs, and we need these cooperations and everything for our future endeavors. Now, regarding the syllabus and other things, fundamentals of artificial learning, machine learning, optimization, a little bit about security also being covered up by the previous session, but it is not fully given as a title here. So security aspects, everything was covered. Then IoT sensor technologies was covered by an industry expert. Then smart technologies and challenges was also being covered. Different applications, smart ecosystem, smart transportation system, smart vehicles, smart grids, smart cities, smart health, everything has been dealt in detail. I hope those who attended enjoyed the session. So now we try to have some feedback about the sessions from participants. So whether anybody can give some feedback, participant side. Participant side, please. 1 or 2 or even more can give the feedback.
Respected sir.
Yeah, may I know whom you are, please tell your name, everything.
Myself, Jitu, assistant
Jitu,
professor.
can you increase the sound a little bit more?
Yeah, can you hear me, sir?
Yeah, now it's okay.
Okay, I'm a research scholar doing my research in Tamil Nadu. Actually, I'm an assistant professor in Kerala, Pala, Kottayam district. So I attended this FDP from the perspective of a research scholar. I can say that the overall sessions means each session was very much helpful for me because so you have already mentioned the each section and whichever sections were handled, especially IoT, machine learning, edge computing, data visualization, etc. So these were the key areas and which were very helpful for me, especially from a research scholar's perspective. And also the sessions were handled by the experts. They explained all the things in detail. So, so it was very helpful for me. And especially the duration was nearly 1.5 hours. So it was easy for us to grasp all these things in a nutshell, especially in a nutshell, and it was not boring. So there were enough breaks, and we got enough occasions for clarifying our doubts, any points, etc. So I would like to say that it was a nice session, and I using this occasion to congratulate all the persons who are behind this FTP. So thank you so much, sir.
Okay. Participants, please. Some more participants can give the feedback.
So good afternoon,
Hello.
sir.
Okay. Okay.
Good afternoon. This is Dr. Ayappan from Pondicherry. I'm working as associate professor in Sri Manakula Engineering College. First of all, I would like to thank for the opportunity to be part of this STTP. Actually, it's my privilege to share my feedback here on STTP on smart computing technologies and applications, organized by MAS College of Engineering, Kuttipuram. So actually, the program was well organized and executed well. So regarding sessions, starting from day one, there are various technical topics discussed in which it creates more awareness and interest on the smart computing area. So I personally enjoyed the various sessions like smart computing technologies and applications, artificial intelligence and neural networks, smart transportation systems, and machine learning and IoT in autonomous vehicles. So I enjoyed this very much. And in addition to this, healthcare applications and systems. And finally, identifying IoT malware and future rates. So all the sessions that creates very innovative and provides a brainstorming one. So I personally felt it's a very great opportunity for me to be in this event. So I thank you for organizing such a great event. Thank you, Sasidharan sir, professor and head, and the organizing committee for conducting a nice program. Thank you.
Any
Hello.
more participants? Yeah, please.
Am I audible?
Yes, sir. Yes, sir. You are audible.
Myself, Rais Ahmad Khan. Myself, Rais Ahmad Khan from Birla Institute of Technology, Mesa, Ranchi. It is my pleasure to attend a program based on the latest technology and application. And we have learned a lot of new topics and smart technology platforms like deep learning, machine learning, IoT, and smart cities concept. So many things are there and practical approaches are there. And thank you to all of the organizing team, all of the member of the team, and all of the eminent speakers. And it was a great, and hope we will meet in the next such event. And very thank you. And in the last, I am saying that in my 20 year of academic life, I have attended such a event function which is started with the Quranic verse Surah Fatiha. Alhamdulillah Rabbil Alameen. It is started and very happy to hear. Thank you very much.
Thank you, sir. Thank you, sir.
Good afternoon, everyone.
Yeah.
I'm Shilpa Suresh, Assistant Professor of AC Department, MES College of Engineering. Although I could not attend all the sessions, since we all being teachers have to complete our academic responsibilities as well, I believe the entire training program was really fruitful for all the attendees. Personally, for me, the entire sessions helped in providing quite a good insights about various smart computing applications and the related researches happening around us. Thanks a lot to the coordinators and organizing team for arranging such an informative training program. Hope to have such sessions in near future as well. Thank you.
Thanks, Silpa.
Sir, you're muted, sir.
Okay. Anyone else? Any more participants would like to give the feedback?
Sir, am I audible?
Yes.
Sir?
Yeah, you are audible.
Okay, I am a student, MTech student from MES. And
Okay.
I would like to thank our HOD, Shashidharan sir, and all the organizing committee for organizing such a program. It was really wonderful to be a part of this. It was really informative also. And the session that inspired me most was machine learning and software engineering by Dr. C.K. Raju sir. And I really thank him for presenting such a wonderful session, and all the sessions were really good. Thank you so much.
Thanks. Yeah. Any more participants? Raju is the.
Yes.
Yeah.
I am. Yes.
Okay.
No,
Fine.
I am offering a toffee to Shana.
Okay. Thanks, Raju. Okay. Any more feedback? Please feel free.
Good evening. Good
Yeah.
evening, sir. Am I audible?
Yes.
I'm Dr. Ramani. I'm Dr. Ramani from UK College of Engineering. I'm the HOD of Computer Science Department. And actually, I'm impressed in two things. I'm totally impressed. Actually, in the time management, actually, sharp at 10, every session starts. And the coordinator, Shashidharan sir, coordinated very well. I'm impressed with that time management, sir. And the second thing is the interdisciplinary aspects. We were involved in all like IoT, machine learning, deep learning, everything. But how it can be used in other disciplines like civil engineering, healthcare, everything were involved in this syllabus. These things actually impressed me a lot, and a very beautiful session and a very informative session by all the speakers. Thanks a lot for the coordinators and especially Shashidharan sir. Thank you.
Thanks, Ramani. Any more? Anyone more? Anyone else? If there is no one else, we shall try to conclude the session. Anyone else? Else we shall conclude. So we shall try to conclude the session then. Comparing team, please take it up further.
Thank you, sir.
Thank you very much, sir. Now I would like to invite Ms. Sahala Parakal, student coordinator, for the vote of thanks.
Good evening, everyone. Myself, Sahala Parakal, and I was given the opportunity to give the vote of thanks. As quoted by Henry Ward, gratitude is the fairest blossom which springs from the soul. I would like to thank AICTE for introducing this opportunity for 6-day short-term training program for all faculties and postgraduate students to open new doors to innovation and information. I would like to convey my sincere gratitude to Dr. A.S. Varadarajan, sir, Principal of MES College of Engineering, Kuttipura, to show the courage and commitment to host this program with the support and coordination of HOD of CAC Department, Dr. Shashidharan Sridharan. I sincerely thank you, sir. I personally thank our faculty coordinator, Professor Shajish Gayu, for guiding us throughout the 6 days of the program. I thank you, sir. And I want to convey our gratitude and honor to have meted and greeted all the guest trainers who took their time out of their busy schedule to come here, share a part of their knowledge, and be with us. Thank you, everyone. I would like to thank Dr. Shashikumaran Sridharan and Dr. Ahmed Vartana for being with us during the last day of our program. Last but not the least, I would like to personally congratulate all the participants who grabbed this opportunity to keep learning new things. Thank you all. Now, there is a gentle reminder for everyone. The link for the online test and overall feedback is provided in the chat box, and there will be 25 multiple choice questions. You need to answer all the questions, and you need to complete the quiz on or before 8:15 p.m. today. And completion of these two forms are also mandatory to be eligible for receiving the certificate. Thus, the concluding ceremony has come to an end. I use this opportunity to thank each one of you for sparing your valuable time to be here with us. Thank you so much. Stay safe, and this is me, Sehela, signing off. Thank you.
So thank you one and all. Thank you Shashikumaran sir. Thank you Ayman Vartana. Okay. So we will meet again. Okay. Shall we sign off?
Okay, sir. Thank you, sir.
Okay.
Thank you very much.
Okay. Okay. Thank you. Thank you one and all.